We are going to continue looking at the cosine law and its applications. In the previous lesson, we looked at how to use the cosine law in order to solve for a side length, as well as how to use the cosine law in order to solve for an angle. This question, we're just going to do one of them, and then the key idea says solve for triangle DEF to the nearest tenth. Now what solve means is to find all of the missing parts, all the missing angles and sides. For this question, we're giving the length of EF is 8 centimeters, that the length of DF is equivalent to 7 centimeters, and angle F is 57 degrees. It does not give us the method to solve, so we could solve using the sine law, the cosine law, or any particular law. However, in order to use the sine law, we must have an angle and its opposite side. For this triangle, we don't have the opposite side of 57 degrees. We don't have the opposite angle of 8 centimeters, and we don't have the opposite angle of 7 centimeters, so the sine law cannot be used. In this particular question, we're given two side lengths and the contained angle. In that case, the only thing we can solve for is side DE using the cosine law. So if we look at the cosine law here, a squared is equivalent to b squared plus c squared minus the product of 2 times b times c times the cosine of a. If we are solving for side x, that's going to be replacing lowercase a, and its opposite angle, 57 degrees, is going to replace or substitute capital A in the cosine law. The other two side lengths, 7 centimeters and 8 centimeters, can replace either side B or C. It won't matter. So let's go ahead and start substituting and solving. So in this case, we have the x squared is equivalent to 7 squared plus 8 squared minus the product 2 times 7 times 8 times the cosine of 57 degrees. Now if you watch and practice along with the cosine law video solving for a side length, just the previous lesson, you'll see the first thing we want to do is calculate all of these products. Again, your calculator is not very good at doing the order of operations for you, so don't put in this entire right-hand side and evaluate it in one step. Okay, so you may want to pause this and try it on your own before we get to the answer. Or you can see what I'm doing on my calculator. Here's the three products. So we have 49 plus 64 minus 60.999, so I'll just call it 61. And that's equivalent to x squared. So x squared is equivalent to 49 plus 64 minus 61. So that sum is 52 right here. So the last thing to solve for that side length is to take the square root. So x is equivalent to the square root of 52, and that's roughly 7.2 centimeters. Okay, so this side length here is 7.2 centimeters. Now, we have not actually solve the entire question. The question says, again, solve the entire triangle. So we have to come up with two remaining angles. We can either come up with angle E or angle D, and it's up to us. In this case, we could use the cosine or sine law if you'd like to, and you might want to pause the video after this. We have all three side lengths on this triangle, so you could use the cosine law to solve for angle E or angle D. Or we have an angle and its opposite side now. We have that 57 degrees is opposite 7.2, so we could use the sine law. What I'm going to do, and you may want to choose to do something differently and pause the video, I'm going to use the sine law to solve for angle D. Okay, so here are my opposites. I'm going to use 7.2 is opposite 57, and I'm going to use that angle D is opposite 8 centimeters. So the sine law says this. It says that sine of angle D over its opposite side, which is 8, is equivalent to the sine of 57, because that's an angle that we have, and its opposite side 7.2. So the first step of algebra is to multiply each side by 8. So we'll have that sine D is equivalent to this quotient and product. And again, on your calculator, press equals multiple times. Your calculator, once again, is not very strong at understanding the order of operations unless you tell it to. So you're going to want to press multiple equals signs, or look at my calculator. I'm going to press sine 57, hit equals. I'm going to divide by 7.2, hit equals. And I'm going to times by 8 and hit equals. If you don't hit equals every time, you might have a different ratio than this. So sine D is equivalent to 0.931856. 0.931856, 1866. So angle D is equivalent to the sine inverse of that. So angle D is equivalent to the sine inverse of 0.931856, 1866, which means that angle D is equivalent to, I can just put in that number by pressing answer, it's equivalent to 68.7 degrees. Okay? So angle D, I'll just write it in here, is equivalent to 68.7 degrees. And finally, to solve for angle E, the easiest way to solve for angle E is angles in a triangle equaling to 180 degrees. So angle E, I would just do 180 minus the remaining angles that we know, which is a 57 degree angle and a 68.7 degree angle, and that gives us an angle of 54.3 degrees. So we have solved the triangle. We have all of the missing sides and all of the missing angles. So in summary, for the cosine law, even though we used the sine law in the last question, here's the summary. The cosine law says that for, and it should be here, any triangle, which is nice, that the side length a squared is equal to b squared plus c squared minus the product of 2bc times the cosine of a. Again, the important thing is that the side length that you're solving for, or the angle that you're solving for, and its opposite are replacing lowercase and uppercase a, regardless of what the triangle is named. In order to use the sine law, so point 2, you must know either of the following two things. You must either know two sides and the contained angle, so that would be this situation here. Let's say I knew these two sides, then I'd have to know the angle that's between them. Okay, so these two sides are these two, and the contained angle is what's right in between them. And secondly, in order to use the cosine law, you could also know all three sides, and this helps us to solve for an unknown angle. So if I knew all three sides, I could solve for any of the angles inside of that triangle.